Good morning, students. Now we are going to continue with differentiation. In the last lecture, we have done the problems which were based on differentiation of implicit functions. Now, the next concept that we are going to study is differentiation of inverse trigonometric functions. Inverse trigonometric functions. It is the next differentiation that we are going to study. Now, you know in inverse trigonometric functions, what are those functions? Now, directly here we are going to find the derivatives of those functions. Now, first let me consider the first inverse trigonometric function given by y is equals to sine inverse of x. Here also x happens to be the independent variable, y happens to be the dependent variable. This function y is equals to sine inverse of x. I will be converting it into an implicit function. What I am going to do? I am going to convert it into an implicit function. So this will be x is equals to sine y. X is equals to sine y. Here I am going to differentiate this function. I am going to differentiate this function on both the sides with respect to x. So differentiating on both the sides with respect to x, what do we get? D by dx of x is equals to d by dx of sine y. D by dx of x will be equal to d by dx of sine y. D by dx of x is 1. Derivative of sin y is cos y into dy by dx. 1 is equals to cos y into dy by dx. This is going to imply dy by dx will be equal to 1 divided by cos y. But what is y? Y happens to be sin inverse of x. So this will be implying dy by dx will be equal to 1 divided by cos of sin inverse of x. This is what is the derivative of y is equals to sin inverse of x. If I want to write it in terms of x only, now you know that y is equals to sin inverse of x. X is equals to sin y. This cos y can be written as root of 1 minus sin square y. Cos y here can be written as root of 1 minus sin square y. Why? Because sin square y plus cos square y is equals to 1. So this will be cos square y is equals to 1 minus sin square y. So cos y will be equal to root of 1 minus sin square y. And what is the sin y? Sin y is x. So this can be written as cos y is root of 1 minus x square. So if cos y is root of 1 minus x square, I can write this dy by dx as dy by dx will be equal to 1 divided by root of 1 minus sin square y, which is 1 divided by root of 1 minus x square. So this is dy by dx. And remember one thing, this inverse trigonometric functions will not be defined for all the values of x and y, because you know that sin inverse x cannot be minus pi by 2 and plus pi by 2. If it is, then this value will be undefined. So the values of x for which it will be not defined is x should not be equal to minus 1 and plus 1. X cannot be equal to minus 1 and plus 1. So there are some conditions. So here the domain and range functions, as you have studied in case of inverse trigonometric functions, in derivatives also the same thing is going to be applied. So here the x value cannot be minus 1 and plus 1. If x is minus 1 and plus 1, this dy by dx does not exist. Similarly, since if y is equals to sine inverse of x, then we have seen dy by dx as 1 divided by root of 1 minus x square. This is the first derivative of an inverse trigonometric function. Similarly, I will be taking y is equals to, I will be taking tan inverse of x. Let me consider y is equals to tan inverse of x. So here, this is going to imply x will be equal to tan y. Differentiating on both the sides. Differentiating on both the sides with respect to x, we get d by dx of x is equals to d by dx of tan y. Remember, this happens to be an implicit function. So 1 is equals to secant square y into dy by dx, or dy by dx will be equal to 1 divided by secant square y. And according to the identity, secant square y can be written as 1 divided by 1 plus tan square y. But what is tan y? Tan y is x. So dy by dx will be equal to 1 divided by 1 plus x square. Right? So this is the derivative of tan inverse of x. Similarly, on similar lines, we can find the derivatives of all these 6 trigonometric functions, inverse trigonometric functions, which I will be writing one by one. So this you can state it as standard derivatives, standard differentials. First one is, if y is equals to sine inverse of x, dy by dx will be equal to 1 divided by root of 1 minus x square. Second one is, if y is equals to cos inverse of x, dy by dx will be equal to minus 1 divided by root of 1 minus x square. Third one is, if y is equals to tan inverse of x, implies dy by dx will be equal to 1 divided by 1 plus x square. If y is equals to secant inverse of x, dy by dx will be equal to 1 divided by x into root of x square minus 1. Fifth one is, if y is equals to cosec inverse of x, dy by dx, here dy by dx will be equal to minus 1 divided by x into root of x square minus 1. And sixth one is, if y is equals to cot inverse of x, dy by dx will be equal to minus 1 divided by 1 plus x square. Conditions as in the case of inverse trigonometric functions. Conditions will be as in the case of inverse trigonometric functions. All the other conditions. Here the x value should not be equal to minus 1 and plus 1. Here whatever you have studied in inverse trigonometric functions, the same conditions are going to be followed here. Right? So in the next class we will be solving more problems based on this. Right? Thank you.